Today we're going to be talking about industrial gateways and converters. My name is Colin. I'm going to be leading you through the presentation. We're going to have one of our engineers here on at the end to answer all of your more technical questions. Our agenda for today, gateways and converters. What are gateways? What are converters? What do we mean when we say those things? When we use these terms, what are gateways, device servers, and terminal servers? Then we are going to be looking at some applications for these devices and then talking about individual products. So before we begin the webinar proper, a little introduction may be needed. We are ICP DAS USA. ICP DAS in Taiwan was established in 1993. Headquarters is located in Hsinchu, Taiwan. ICP DAS USA, that's us here in Lomita, California, was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers, and we work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, meaning they are lead-free. So back to gateways and converters. There are three types of product, all of which perform very similar functions and are often confused. Unhelpfully, nomenclature around these products by different manufacturers is often vague, and different devices that do different things go by the same names. Any of them may be called a converter, a server, or a gateway. It's important to keep these differences in mind, and the first device we're going to be talking about is a gateway. So in a nutshell, a gateway is a device that connects two networks that use different protocols. They're used for connecting modern systems with legacy hardware. And data is usually stored on the gateway and queried by the controller instead of converted or rewrapped. So it works like a network switch, but for working between different kinds of network. So it's important to understand that gateways don't just translate messages for the most part. So in this example, we're looking at a Dali Gateway, which is not one of our more popular items, but it is interesting for an example. Dali is a lighting control protocol. So in this example, Dali data from the field from your end devices here would be stored on the gateway, and data requests are performed on that stored data. So read requests are not passed through to the field. In case of write requests, the write is applied to internal data, and then the update is sent to the field as a Dali message. With this gateway in place, there's no Dali on your Ethernet network or your RS-45 network, and there's no RS-45 serial on your Dali network. With gateways, data requests seem to be converted, but they're not at a protocol level. There's a lot more management and protocol translation going on there. So this gateway integrates lighting data and controls with the rest of building automation. DG521, the gateway we're talking about right now, is manufacturer agnostic, but some good examples of the controllers it works with would be our touchpad controllers like the TPD430 shown here, which is a little wall mount unit, or one of our WinPaks, which is a Windows embedded programmable automation controller, or through the USB interface, a PC controller. Okay, so terminal servers are kind of on the other end of the spectrum from gateways. Terminal servers are usually media converters that don't tamper with the message. A terminal server captures data arriving at the serial port, or usually wraps it up into an Ethernet packet and then delivers the data to another location. The terminal server doesn't do any conversion or translation. It just delivers data as it came. So when two terminal servers are linked to each other across a network, serial data arriving at one end just comes out the other end, and vice versa. So terminal servers are usually used to connect RS-232 end devices to an Ethernet LAN. They're used for like I said, that raw data, TCP, UDP connection, console management, serial tunneling, back-to-back configuration. That is where that's just where serial data arriving at one end just pops out the other end without messing with it. Okay, here's an example. We have a product called M2M710D, which is a remote tunneling terminal device, and it's used for remote maintenance. Okay, so here we can see a remote tunneling application using M2M710D, our remote terminal unit used for M2M diagnostics and communication. In this example, we're using two modules to create a tunnel between an offsite controller and a PLC on the factory floor over the internet. This creates a virtual bridge that makes it as though the PC controller were connected directly to that PLC over RS-232. Okay, device servers. Terminal servers are commonly, but not always, installed as linked pairs. Device servers are usually installed as standalone media converters. They are very useful in that they allow a device that only speaks the serial version of a protocol to be connected to an IP network and to be treated as if it was IP capable, supporting the IP variant of the protocol. A device server is different from a gateway in that a gateway is a link between two completely different protocols, whereas a device server is generally only converts media with a couple minor differences, say between the serial and the IP versions of the same protocol. So functionally, a device server is somewhere in between gateway, terminal server, and a gateway. This type of product includes what many people think of as a converter. Terminal servers are often used in linked pairs, like we saw with M2M710D in that example, whereas device servers are used as standalone media converters. And generally, device servers convert media for like a serial to Ethernet and not protocol. So here is an example of some of our TDS modules connecting serial devices to the Ethernet network. And here's an example of how one of our gateways wraps controller input and sends it to the appropriate devices on the Modbus RTU network. So you can tell this is what's happening when there's actual conversion going on. And here's a couple more simple examples of how our gateways and device servers work, including a Wi-Fi bridge that you could call a terminal server or a device server, depending on whether it's used as a bridged pair or as a media converter between Ethernet and Wi-Fi. But for a slightly more in-depth example, here's a story from one of our previous customers. We had an aviation customer. Let's see. We were contacted by a systems integrator with an inquiry in regards to the need for highly precise data acquisition modules capable of serial communication and networking via DeviceNet, one of our field bus options. The said application was used by an avionic hardware fabricator. The scope of the project was pretty in-depth. The customer was monitoring vacuum over an extremely large tabletop surface via a flush mount inductive eddy current sensor. The production version of the measurement device would implement over 700 sensors to monitor the tension and vacuum across wing panels mounted on the table for CNC machining. The inductive eddy current sensors would measure the air gap between the table and the sheet metal surface being pulled down with the vacuum. Each sensor would be transmitting a 4 to 20 milliamp analog signal to represent the increment of measurement. The challenging aspect of this application was the required use of DeviceNet as both the serial interface as well as the infrastructural communicative network. Because of the large scale of data acquisition needed for the project, ICP recommended the implementation of the I-7017C, which is one of our analog data acquisition modules. The I-7017C is an 8-channel current-specific analog input module capable of sampling full 16-bit data streams at 10 samples per second and allowing user-selectable channel configuration. By implementing upwards of 89 modules in the projected application, the end user would be able to amply monitor the data acquisition needs via DeviceNet-based network. The task of converting the acquired data would be placed on ICP DAS's I-7241D DeviceNet converter. With the I-7241D in place, all 89 modules in the test were daisy-chained in an RS-485 network to simultaneously monitor the tabletop vacuum and transmit data over DeviceNet to the data logging module. So that is a kind of a better, more in-depth, real-life example of how these converters are used. Now, moving on to some of the specific modules that we talked about, the DG521, again, not one of our most popular items, but a very interesting one, I think. It's an RS2 232 485 USB to Dali. That's a digital addressable lighting interface gateway. It's a communication gateway between a lighting control network and automation controllers. It can be powered over your Dali network or by an outside power source. You can enable that through a switch. It has your Dali connection, your serial connections, and a USB-B connection. And that's kind of redundant, but it does connect your lighting network to the rest of building automation. One of the gateways that we're talking about is the GW7472 Ethernet IP adapter to Modbus RTU master and Modbus TCP client gateway. It's helpful for data exchanging between Modbus RTU / Modbus TCP networks and Ethernet IP networks. It reads the register data from Modbus RTU slaves as well as Modbus TCP servers and publishes these data to the input register data of the Ethernet IP scanner. The output data transmitted publishes the data to the input register data of the The output data transmitted by the Ethernet IP scanner are updated to the register data of the Modbus RTU slaves / Modbus TCP servers via GW7472. In order to save installation space, GW7472 is offered in an amazing tiny size that makes it easy to install anywhere, even directly attached to a serial device or embedded into a machine. It also features a powerful 32-bit MCU to efficiently handle network traffic, and provides the IEEE 802.3AF compliant classification power over Ethernet with a standard Cat5 cable. Another module that we've been talking about are the TGW700 Series. This is a family of Modbus TCP to RTU ASCII gateways that enable a Modbus TCP host to communicate with serial Modbus RTU ASCII devices through Ethernet networks. They eliminate the cable length limitation of legacy serial communication devices. The TGW7000 serial device servers can be used to create a pair connection application, as well as a serial bridge or serial tunnel application, and then route data over TCP IP between two serial Modbus RTU ASCII devices, which is useful when connecting to mainframe computers, servers, or other serial devices that use Modbus RTU ASCII protocols and do not themselves have Ethernet capability. The TGW712 and 715 are some of our most popular modules. The 712 features an isolated RS-232 COM port. They all come with 10/100 base TX Ethernet with auto-negotiating auto MDI MDX crossover, and the T stands for tiny form factor and low power consumption. So see, these are some of our high-function, low-cost, low-space modules. Here's an example of the TGW700 Series selection table. I'll give you an example of just some of the modules that we have available within the different serial and different COM port configurations. Okay, we already talked about the M2M710D, but I'll just go over some of the highlights. The M2M710D module is specially designed for the remote maintenance and upgrading of serial to network applications. It is suitable for the harsh industrial field. It provides two major technologies for networking: the pair connection, which provides TCP data tunneling between two serial devices, and remote serial data transmission between over the other technology is remote serial data transmission over Ethernet between local and remote sites. This means the maintenance engineer can directly check and diagnose the device or PLC as if they were on site. And then some of our device servers, more popular device servers, are the TDS700 series. Again, it's a family of device servers with tiny form factor. They're designed to add Ethernet and internet connectivity to RS-232 and RS-422/45 devices. They provide virtual COM ports to PC controllers to monitor and access serial devices without software modification. Can also be used, like the M2M710D, to create a pair connection. TDS700 is a series of serial to Ethernet device servers that are designed to add Ethernet and internet connectivity to any RS-232 and RS-422/45 device, and to eliminate the cable length limitation of legacy serial communication. By using the VXCOM driver utility, the built-in COM port of the TDS700 series can be virtualized to a standard COM port, PC COM port in Windows. Therefore, users can transparently access or monitor serial devices over the internet, Ethernet, without added software. And then here's the selection table for the TDS700 family. This is just a few. I wanted to show off some of the different configurations. And then finally, we mentioned this just briefly in one of the application examples, the WF2572, which is an industrial Ethernet to Wi-Fi bridge. The device only needs to connect the Ethernet cable with WF2572 to create an IEEE 802.11 wireless personal network. The interface between Ethernet and Wi-Fi uses transparent transmission so that it can convert Wi-Fi to Ethernet without complex settings. The WF2572 also supports dual bands. 24 gigahertz is usually more crowded than 5 gigahertz. Therefore, 2.4 gigahertz suffer more interference than on the 5 gigahertz. Right, this is a plug-and-play module. Like I said, it uses transparent transmission to convert your wired Ethernet to Wi-Fi without having to mess with the settings. It also offers a couple options for encryption, and like all of our products is industrial related, has a high operating temperature range and is suited to any kind of harsh industrial environment. So that about wraps it up for today. We're going to move on to the question and answer portion of the webinar. So feel free to type your questions into the chat box, and we'll have one of our engineers get on the line, and hopefully we can answer any questions you have. Okay, not seeing anything in the chat. Oh. Would it be possible to obtain a copy of today's presentation? Yes. Go ahead and send us an email at sales@icp-usa.com, and I'll go ahead and send you a copy. Oh, here's some. Okay, it looks like that's going to be all the questions for today, unless we had anybody who was just dying to get their question answered. Doesn't look like it, so I would like to thank you all for coming. Please stay tuned for next month's webinar. We're going to be talking about our WinPack, Windows-based programmable automation controllers, and I am pretty excited about it. So please check your inboxes for some updates from us. If you have any more questions, please feel free to contact us anytime through email or 9 to 5 Pacific Coast time through our telephone. You can always visit us online, www.icp-usa.com. And please, please, please follow us on, please connect with us on LinkedIn if you have a LinkedIn profile. So, thank you very much for coming.